Our goal moving forward is to solve our polynomials. As we're working towards solving a polynomial, there's going to be a couple things we're going to build on. First one we're going to talk about is the Fundamental Theorem of Algebra. Okay? The Fundamental Theorem of Algebra is pretty basic. All it's saying is based on the highest exponent, that's how many solutions our equation is going to have. Okay? So, Fundamental Theorem of Algebra, based on the highest exponent, that's how many solutions we will have. Okay? You've seen this in the past. With linear functions, you get one answer. With quadratics, we got two, even if they were repeated roots. We'll talk about that. So here, we have a 6x cubed. That's telling me I am going to have 3 solutions. Okay? 3 solutions. This is where it gets a little bit tricky, though. Okay? Of these 3 solutions, all 3 might be real answers. So I'm going to say real numbers. What, Miss Nelson? Real numbers? Well, if we can talk about real numbers, that means we can talk imaginary numbers. We could have 1 real solution and 2 imaginary solutions. Imaginary numbers, what? We'll talk about it in a bit. Okay? Imaginary numbers always travel in pairs. Remember that. All right? If we have 3 real solutions, there's options here as well, meaning all 3 could be nice, rational answers. That's what we're going to be talking about here in a bit. Okay? 3 rational answers. Or we could have 1 rational answer and 2 irrational. Okay? Irrational numbers, they also always travel in pairs. So we're going to keep that in mind as well. So we've got to look for 3 solutions. On our previous examples with our division, we've been able to go through and say, is this divisor a factor of the polynomial? So we went through our synthetic division, we get a remainder of 0. Yes, it's a factor. Or no, it's not. Well, now I have my polynomial and I want to know what the answers are. But I'm not given any hints. I'm not given a divisor to test. So that's where we step in with our second theorem we're going to talk about today. This is called the Rational Root Theorem. So with this theorem, this is going to help us build a list of numbers to test, factors to test, okay? Or we just have to pull numbers out of left field, right field, plug them in, see if they work. If they don't work, we're left guessing. This rational root theorem is going to give us a smaller list to guess. To build our rational root list, what we're going to do is we're going to take the factors of our constant. So the constant is always the number without the variable. We're going to take the factors of the constant and we're going to divide those by the factors of the leading coefficient. Okay, so right now we're just building that list to help us guess. So I'm going to take the factors of the constant, which is 1 and 3. I am going to divide that by the factors of my leading coefficient. So the factors of 6 are 1, 2, 3, and 6. Okay? So I'm going to go through and I'm going to actually split this up. 1 divided by 1, that's 1. 1 divided by 2, that's 1/2. 1 divided by 3 is 3. 1 divided by 6 is 1/6. 3 divided by 1, that's 3. Oh, silly me. 1 divided by 3 is 1/3. And now, 3 divided by 1, that's 3. 3 divided by 2, that's 3/2. 3 divided by 3, that's 1. We already have it, so I don't have to list it again. 3 divided by 6, that's 1/2. Already listed. I don't have to build it again. So, rational roots. These are the only numbers I'm now going to test. I'm not going to go in and see if 5 is going to be a solution for this polynomial because it's not on this list. But if we end up in this scenario where we only have one rational answer, the other two are irrational or imaginary, there's got to be other ways to work through that. So for now, we're just building that rational root list. Okay, the next video I'm going to come in and I'm actually going to use the rational root list with a couple other hints.